Welcome to Artificially Intelligent, the podcast that is written and performed entirely by AI. I'm Alex, and today we're diving deep into a fascinating topic that is reshaping manufacturing as we know it.
And I'm Taylor. Today's episode explores the revolution of 3D printing in industrial manufacturing, a technology that transforms digital blueprints into real-world objects layer by layer. Let's get started.
3D printing, also called additive manufacturing, has evolved from a prototyping tool to a major production method. It enables complex geometries and rapid design iterations that traditional subtractive methods simply cannot match.
That's right, Alex. Its ability to build objects by adding material incrementally opens up endless design possibilities. This method allows for intricate details and customizable products, pushing innovation in industries like aerospace, automotive, and even consumer goods.
Taylor, how exactly does 3D printing complement traditional manufacturing processes? Is it set to replace them entirely, or do both methods coexist?
They largely coexist. Traditional methods excel in high-volume production, while 3D printing shines in rapid prototyping, small-batch manufacturing, and producing complex, customized parts. Companies often adopt a hybrid approach to optimize efficiency and flexibility.
The environmental impact of manufacturing is another key factor. Traditional methods can generate significant waste. How does 3D printing address sustainability concerns in production?
Additive manufacturing uses only the material necessary to create a part, minimizing waste. This efficiency, combined with the potential to use recyclable or biodegradable materials, makes 3D printing a promising option for more sustainable production practices.
It's amazing to see technology driving not only innovation, but also environmental responsibility. Now, let's discuss design. How does 3D printing impact the creative process for engineers and designers?
With 3D printing, designers are no longer limited by the constraints of conventional manufacturing. They can experiment with organic shapes, internal structures, and complex geometries. This freedom leads to more innovative products and allows for iterative design improvements with minimal cost.
The customization aspect is revolutionary. Manufacturers can now tailor products to meet specific customer needs without retooling entire production lines. How do you see this affecting the supply chain dynamics?
Localized production is one big advantage. Instead of mass-producing standardized items and shipping them worldwide, businesses can produce customized products near the point of demand. This not only reduces shipping costs, but also shortens delivery times and lowers carbon emissions.
Beyond supply chains, there's the matter of speed. Traditional tooling can take weeks or months, but 3D printing can dramatically cut production time. How are businesses capitalizing on this rapid turnaround?
Many companies are integrating 3D printing into their R&D production processes for quick iterations. By shortening the design-to production cycle, firms can respond faster to market trends and consumer demands. This agility is a huge competitive advantage.
Speaking of competition, what are some of the major challenges that businesses face when adopting 3D printing technology on a larger scale?
There are a few hurdles. High-quality 3D printers and advanced materials can be costly. Additionally, there are limitations regarding build size and material properties, which can restrict certain applications. Companies must balance the benefits of customization with the practicalities of production volume and material performance.
Intellectual property concerns also come into play. With digital files at the heart of 3D printing, how do companies protect their designs from unauthorized replication?
Intellectual property protection is a significant issue. Firms are exploring secure digital rights management and encryption methods to safeguard their designs. While some are even considering blockchain-based solutions for traceability, it remains an evolving area that requires careful strategy.
It's clear that 3D printing offers tremendous opportunities, but the technology still needs to overcome technical and economic barriers. Have there been any recent breakthroughs that signal a turning point for the industry?
Absolutely. Advances in materials science are expanding the range of printable materials, from high-performance polymers to metal alloys. Additionally, improvements in printer speed and resolution are making 3D printing more viable for production runs, which is encouraging for large-scale industrial applications.
The evolution of printer technology itself is impressive. How have new developments in printer design and software impacted the overall effectiveness of additive manufacturing?
Newer printers offer enhanced precision, faster build times, and improved multi-material capabilities. The accompanying software has become more user-friendly, allowing for better design optimization and error reduction. These innovations are making 3D printing more accessible and reliable across various sectors.
I find it fascinating that industries once considered separate are now converging through 3D printing. How do you see this technology influencing collaboration between different sectors, such as manufacturing and design?
Collaboration is key. Cross-industry partnerships drive innovation by merging expertise from design, engineering, and material science. This collaborative environment accelerates research, improves product quality, and fosters a culture of continuous improvement across multiple fields.
That kind of interdisciplinary cooperation can transform business models entirely. Companies can now experiment with new products and even enter markets that were previously out of reach due to high manufacturing costs. What does this mean for startups and small businesses?
For startups, 3D printing lowers entry barriers by reducing the need for large capital investments in traditional manufacturing. It allows for rapid prototyping and on-demand production, enabling small businesses to compete with established players by offering niche, customized solutions.
And for larger companies, the technology can lead to more agile production methods and innovative product lines. It seems like 3D printing is democratizing manufacturing in a way that benefits everyone from small enterprises to industrial giants.
Precisely. By enabling both mass customization and rapid iteration, 3D printing fosters a more dynamic marketplace. Companies can adapt quickly to changes in consumer demand and reduce the risk associated with large-scale production runs.
Let's not forget about quality control. With traditional methods, maintaining consistency across large production runs is a challenge. How does 3D printing handle quality assurance, especially when parts are produced in small batches or even on demand?
Quality control in additive manufacturing often involves integrated monitoring systems and advanced software that tracks every layer of the build. Automated inspection tools help identify defects early in the process, ensuring that even customized products meet high-quality standards.
That kind of precision is essential, especially in industries where safety and performance are critical. How are sectors like aerospace and automotive incorporating 3D printing while maintaining stringent quality requirements?
These industries are heavily regulated, so extensive testing and certification processes are in place. Manufacturers use 3D printing primarily for non-critical components or as part of a hybrid production process. This ensures that while innovation is encouraged, safety and reliability remain uncompromised.
As we explore the future of manufacturing, what role do you think government policies and industry standards will play in shaping the adoption of 3D printing?
Government policies can accelerate adoption by offering grants, tax incentives, and research funding. Meanwhile, industry standards ensure that products meet safety and quality benchmarks. Both elements are essential for fostering an environment where additive manufacturing can thrive and reach its full potential.
It's evident that a supportive regulatory framework can significantly boost technological integration. What advice would you give to companies looking to integrate 3D printing into their existing operations?
Companies should start small, using 3D printing for prototyping or low-volume production before scaling up. Investing in employee training and collaborating with research institutions can also help. The key is to adopt a gradual approach, integrating the technology where it offers the most value while continuously learning from early implementations.
Let's shift our focus a bit. Many of our listeners are entrepreneurs curious about how 3D printing can create new business opportunities. What emerging trends do you find most promising in this area?
One exciting trend is the rise of on-demand manufacturing platforms. These platforms allow businesses to produce custom parts without maintaining large inventories. This flexibility can lead to new business models centered around rapid product customization and localized production networks.
The potential for on-demand production is vast. It not only reduces overhead costs, but also minimizes waste by producing only what is needed. How do you think this will affect the overall business landscape in the coming years?
On-demand manufacturing is likely to disrupt traditional supply chains by shifting production closer to the end user. This decentralization can lead to faster delivery times and more responsive customer service, ultimately reshaping how products are designed, produced, and distributed.
Our discussion today has covered a wide range of topics, from technical breakthroughs and sustainability to market dynamics and future trends. It's clear that 3D printing is not just a technological novelty, but a driving force behind modern manufacturing innovation.
Indeed, Alex. The integration of 3D printing into manufacturing represents a paradigm shift, one that combines creativity with efficiency and customization with mass production. It's an exciting time for the industry, and the possibilities seem endless.
Before we wrap up, I want to highlight that this entire conversation is a demonstration of what advanced AI can achieve. Our podcast is written and performed entirely by AI, showing how technology can create meaningful dialogue on complex subjects.
That's a great reminder, Alex. Our discussion today not only explored the intricacies of additive manufacturing, but also showcased the creative potential of AI in content creation. It's a testament to the innovative spirit driving both technology and storytelling.
As we look ahead, the future of 3D printing appears bright. With ongoing advancements in materials, printer technology, and collaborative innovation, the landscape of manufacturing is set for transformative change over the next decade.
The synergy between digital design and physical production will only grow stronger. Whether you're an established enterprise or a budding startup, embracing 3D printing can unlock new opportunities and drive competitive advantage.
I hope our listeners found today's exploration insightful and inspiring. Thank you for joining us on this deep dive into the world of 3D printing and its impact on modern manufacturing.
It's been a pleasure sharing these insights with you all. We encourage you to continue exploring how emerging technologies can revolutionize traditional industries and spark innovative business models.
Until next time, stay curious, stay innovative, and stay artificially intelligent.